This is section 3.2, second video. We're going to prove the alternate interior angle theorem. So if you go back to what we looked at last time, we have a postulate. It's called the corresponding angle postulate. It tells you anytime you see corresponding angles, they're congruent to each other. You don't need to prove postulates, but you do need to prove theorems. The alternate interior angle theorem tells you that alternate interior angles are congruent. Well, we need to prove that that's true. And we can use anything we want, any postulate or any definition or any property that we've had in the past. So here's what we're given to use. We're given that line P is parallel to line Q. That's how you read that. Notice how it shows those marks in the diagram. You need to prove that angle 1 and angle 2 are congruent. Notice how angle 1 and angle 2 are alternate interior angles. So given that these lines are parallel, can you show that these two angles are congruent? That's what we're hoping to do. So you need to use line P parallel to line Q. That's your given. I can't spell given. Now, if you have parallel lines, what does that do? That creates congruent angles in certain spots, like these spots right here. I know these angles are congruent to each other because they're corresponding angles. If the lines weren't parallel, I wouldn't be able to say that, but since they are, I can say angle 1 is congruent to angle 3 because of the corresponding angle postulate. Okay, now we need to show that angle 1 is congruent to angle 2. Well, how are we going to do that? Well, what do you know about angle 2 and angle 3? Look at them. They're congruent to each other also. How come? What kind of angles are those? Those are vertical angles. We already proved the vertical angle theorem, so you're allowed to use it. So you can prove something else. So we're using this shortcut to prove a new theorem, so we can use that in a different proof. Okay, well, notice how all three of these angles have the same arc on them now. If this one's congruent to this one, and this one's congruent to this one, wouldn't these two be congruent too? Definitely. What's that called? If two angles are congruent to the same angle, they're congruent to each other. That's your transitive property. It's a property of congruence because we're talking about congruent angles. Okay, so we just proved this theorem. You are now allowed to use it anytime you want. Okay, here's another theorem. It's the alternate exterior angle theorem. If two lines are cut by a transversal, here's your two lines, and they're parallel, that's the important part. The alternate exterior angles are congruent. So angle 1 and angle 8 are alternate exterior. They have to be congruent. Angle 2 and angle 7, they're also alternate exterior. They need to be congruent. That's what the theorem says. Now, you can prove this, and it's very similar to the last theorem that we proved. Okay, so we have congruent corresponding angles. We have congruent alternate interior angles. Now we have congruent alternate exterior angles. Theorem 3.3. Theorem 3.3 is the consecutive interior angle theorem. It talks about the relationship that the consecutive interior angles are going to have when the lines are parallel. When they're parallel, your consecutive interior angles are not going to be the same because one's acute and one's obtuse. They can't be the same. But the relationship that they have is they add up to 180. They're supplementary. Okay, so let's do this easy example, just like we did at the beginning of last video. except this time we're going to use the postulate and our theorems that we just learned. You have parallel lines and a transversal. That's a 73-degree angle. Angle 4 is alternate interior to it. So aren't they the same? This angle is also corresponding to angle 1. So those are the same. Angle 1 and angle 6 are alternate exterior. So those are the same. Your 4 acute angles are 73 degrees. Now, we also have 4 obtuse angles. And that theorem that we just talked about, the consecutive interior angle theorem, will help you here. These are consecutive interior angles. They're not the same because that's acute and that's obtuse. They're supplementary. Now, if you know this angle is 107, wouldn't its alternate interior angle be 107? Wouldn't its corresponding angle be 107? And then this one's alternate exterior angle is going to be 107. So the way we did this was we used the theorems and the postulates that we talked about in this section. That's the language that we need to use. If that's too much for you, you can just keep it very simple and do that whole thing where if you know these using vertical and linear pairs, and you know these 4 angles, you could just transfer them up to here. It's the same concept.